Welcome. Welcome to our build session. Hi, my name's Matt Farmer. This is Build Scalable Hybrid Integration Applications that run anywhere with Azure Logic Apps and Azure API Management. I'm going to be joined virtually by my colleague Miao Zhang as part of this session. Thank you for joining us, and we hope you find the session useful. So in this session, we're going to be talking about Logic Apps and API Management. As this is built, there's probably a whole range of people who have a lot of experience with this technology, some who are not so familiar. So we're going to introduce why we're talking about these things together, a little intro to what they do, and then we're going to talk through some of the new features that are either been just released in the case of API Management, and we've got some brand new stuff from Logic Apps that we're going to talk through, and then we're going to quickly finish off by talking about the future and how you use these services in hybrid scenarios, which is one that's very, very top of mind for a lot of our customers. Taking away from this session, we want to make sure that you understand both services. And really, making sure that you understand, if you're a developer, which many of you I'm sure are, how you can really take advantage of these services and why they should be top of mind for things that can really help you be more effective and accelerate great development experiences. We're going to show you some of those new features, either ones we've released or ones we're about to share with you. And we're also going to talk about connectivity and hybrid with both services. So quickly, just to frame up what we're talking about, we talk about this session in terms of integration, and traditionally, integration has perhaps been a term that's associated with expensive, specialist, complicated middleware. But really, what integration is all about is connecting applications, system data, people, and things. It's just making sure those things can talk to each other, and that's really why we're talking about API management and Logic Apps together, because whilst we talk about them as an integration technologies, really the use of APIs, interfaces, things like visual designers, connectors and adapters and transformations used to be the domain of those specialist tools, but that's no longer the case. These are all techniques you can use to build almost any application. And that's why these days, basically, integration applications are all applications or vice versa. So let's quickly summarize what Azure Logic Apps is for those who are unfamiliar. We start with the picture of what the visual designer, and this is the thing most people associate with Azure Logic Apps. It's a tool that allows you to build applications, flows of logic using visual design tools, and that connects a whole bunch of different endpoints, whether they be things like software as a service or APIs, or event-driven applications together. Now, first question you may be asking if you're a developer is, why would I do that? Why would I do that when I can write my own code? And generally, the answer I give to this question is something like, is all the code you write the most important code you could be spending your time on? Do you really enjoy writing things like connecting to endpoints? Logic Apps is a way to do more with the time you have, to make it part of your suite of tools as a developer to build applications. To summarize the kind of main components, connecting everything together is one of the key things. So it has a range of 300 or more connectors to things we use every day, and more as part of the applications we build at. So things like connecting to SaaS services, software as a service. So Salesforce, Microsoft Dynamics, ServiceNow, as well as things like Office and a whole host of other ERP systems and SaaS systems. We have connectors in the box that allow you to connect to those services in a repeatable way, so you don't have to build them yourself. So you can simplify those parts of your application very quickly. It's low code, but low code doesn't have to mean low skill. What it can mean is allowing you to do things more quickly, so you can focus your time where your skills are really, really necessary. And of course, you can mix and match. So you can mix connecting to a service with connecting to another application that you've written or a piece of code in a function. And by doing that, that gives you flexibility and accelerates your ability to build applications quickly. And then serverless. Obviously, serverless is a word a lot of us have heard in terms of cloud computing. Logic Apps very much embodies what serverless is supposed to do, in that its default SKU, the way in which we deliver it to you, is one where you only pay for what you do. It can be completely event driven and on demand, so you only use it when you really need it, and you pay for what you use. But the real benefit of this is the ability for you to do stuff really quickly. You don't have to worry about provisioning infrastructure. You don't have to worry about planning out the development of your application in quite the same way. You can get very quickly value and realize it by connecting to sources of data or applications within your business and build apps and see their value quickly. And just to summarize how you can consume it, I mentioned that it was serverless, but we also have a dedicated tier. So Logic Apps can be something that is used directly in the internet, just connecting things like SaaS services where you're already going between two internet endpoints, or we also have a dedicated tier that you can lock away in a virtual network. You can have connecting to more highly secure services, and also protect yourself from things like sharing those resources with others. So we have different options depending on what kind of customer you are and how you want to use the service. So that was a very, very quick introduction to Logic Apps. I'm going to hand over to Meow now, who's going to talk us through API management.
Thank you, Matt. Hi, everybody. This is Meow from the API management team. In the next 20 minutes or so, I'm going to talk a little bit about API management, focusing on a few things that would help you, the developers, to build and operate hybrid integration applications. First of all, in case you are not familiar with API management, here is a quick overview. Architecturally, API management contains three key components. In the heart of the product is a highly scalable API gateway, which sits in front of your backend APIs and serves as the single point of entry, the front door, and the facade for all your APIs. This allows you to hide all your APIs behind a single domain name, decouple your front-end applications from the backend APIs, configure authentication and authorization in a central place, collect telemetry for all your APIs, enable caching, transform and modernize your APIs, and so forth. In addition to the gateway, API management comes with a developer portal. This is a self-service portal that allows developers to discover, to learn, and to get access to all your APIs. Finally, there is the management plane, which is our ARM APIs for configuring and managing the API management instance. And obviously, API management integrates well with other Azure services so that you can easily use them together with API management. In a nutshell, API management provides a facade and a front door for all your APIs, and it also allows frictionless consumption of the APIs via the developer portal. Now that we have done the level set, let's talk about a few things that you as developers will probably be interested in. First, let's talk about our deployment options in a hybrid and a multi-cloud world that we are in today. If you have been following our product, you may know that previously all the components of API management are hosted on Azure as a managed service. It works really well with backends hosted in Azure. The setup is very efficient and optimal. However, as you pull in backends in other public clouds or on-premises, since the gateway is in Azure, all requests have to go through Azure, which adds latency and complexity in terms of setting up virtual network to connect to on-premise, right? However, it kind of breaks down when there are consumers that are in the same environment where the backends are deployed. In this case, the API traffic has to travel all the way to Azure and back. This is grossly inefficient, not to mention sometimes it runs into concerns like security, compliance, and egress data transfer charges. To tackle this problem, we announced the general availability of the self-hosted gateway last month, which allows customers to take the API Management Gateway component and deploy it anywhere close to their backends. It's a much better architecture. API traffic can be optimized to hit the API gateway in the same environment. It also allows traffic to stay within the same environment for security and compliance concerns. With the Azure hosted and self-hosted gateways, it allows customers to manage all of their APIs no matter where they are deployed. It could be in Azure, in other clouds, or on-premises. To sum it up, the self-hosted gateway is packaged as a Linux container. It can be hosted anywhere. Functionally, it is equivalent to the cloud-hosted container. The self-hosted gateway is federated with an API management service. It requires only outgoing connectivity to Azure to pull configuration and push telemetry back. The gateway can be deployed anywhere that Docker is supported. For example, you can try it out with Docker, Desktop, or Minikube. Obviously, Kubernetes is the recommended environment to deploy it for the simplicity of deployment, scaling, updating, and so forth. And as I mentioned, the self-hosted gateway is now generally available. Now let's talk about our pricing models. As a single product, we offer complementary pricing models for customers to choose from. Traditionally, we had the dedicated tiers, as you can see in the right column here in this table. Last year, we released a new tier called Consumption, which is in the left column here. The two flavors of tiers share some common properties. For example, there is no infrastructure to provision or manage since API management is a managed service. They all come with built-in high availability. The Consumption tier comes with a few serverless properties, such as built-in auto-scaling up and down to 0 when there's no traffic, a consumption-based micro-billing model, which means that we charge customers based on the number of API calls. If there's no call, there's no charge. For the Consumption tier, there's no reserved capacity. They will be activated on demand, and it is a multi-tenant architecture with shared resources. In comparison, the dedicated tiers are built based on reserved capacity, so you know that you have an instance that's always on and it has dedicated resources. The two models are complementary. As a developer, you can choose between the two based on your scenario. Here are some target use cases for the Consumption tier. Since it comes with a number of serverless properties, it is a good fit to use together with other serverless resources such as functions and logic apps. It's also a good entry point of API management and for non-production environments. Given its built-in auto-scale feature, it is also good for APIs with spiky traffic. Next, let's talk about observability. As developers, it is very important for you to have all the options to monitor the usage and health of your APIs, as well as having the tools and the logs for debugging and troubleshooting any issues. As a result, we provide a variety of options out of the box. The API Inspector is a great tool to test your APIs. It gives you a detailed trace of what happened during the processing of this request, and you can also see errors and latency at each step. For analyzing your APIs, we also have built-in reports that give you a good understanding of the usage and health of your APIs. Additionally, we have Azure Monitor metrics so that you can configure alert rules. For example, you can trigger an email when there is a large number of unauthorized calls, or you can trigger Azure Monitor Autoscale when the capacity metric goes above a threshold. For each API request, we also emit a log entry through Azure Monitor logs. You can easily query the logs to discover insights, patterns, or troubleshoot your APIs. We also have integration with Application Insights, which is great for end-to-end tracing. And finally, we have integration with Event Hub, so you can emit custom events from API Management to Event Hub for additional scenarios, such as building a custom real-time dashboard. For the new self-hosted gateway, as I mentioned earlier, it is running in your environment. It is still possible to send metrics and telemetry to Azure through Azure Monitor and Azure Application Insights. Additionally, you have the option to emit and persist logs and metrics locally. For logs, we support syslog, journal, and JSON, so you can build a pipeline using popular tools like FluentD and Splunk. The logs are also sent to standard streams, so you can simply read them using commands like kubectl logs or docker logs. If your self-hosted gateway is deployed in Azure Kubernetes service, you can also use Azure Monitor for containers to collect the container logs. For metrics, we support statsd, which is a popular protocol. You can emit the metrics through statsd and view them using open source tools like Prometheus. Last but not the least, we want to provide you with the best tooling to work with API management. We know that automating the deployment of API management is a challenge that many customers struggle with. To help with that, we developed a resource kit that includes guidance and open source tools to help you to automate your deployment into a shared environment. For the interest of time, I will not delve into details here, but you can visit this link to find out more information about the resource kit. And last year, we released a VS Code extension, which has been received really well with more than 68,000 downloads already. The goal of the extension is to increase users' productivity. It comes with a convenient resource explorer, which allows users to quickly browse and manage your API management instances and resources. Policy editing is a focus area. The extension leverages the power of VS Code as an IDE to provide an advanced policy editor with many powerful features such as syntax check, IntelliSense, reusable snippets for common scenarios, and so forth. Moreover, the extension integrates the REST client so that you can test your APIs right there in the same context without switching to another application. Finally, the extension also integrates with our DevOps Resource Kit that I just mentioned, so that you can right-click on the API and extract all configurations of that API into a set of ARM templates so you can migrate the API to another environment. Okay, with that, I will do a quick demo of API management, showing some of the features that I just mentioned. Okay, I'm here in the Azure portal, and this is my API management instance. The first thing I want to do here is that I want to import a Logic app and publish it as an API through this API management instance. To do that, I will click on the APIs menu here, and this is where I can create and manage all my API facades in this API management instance. And as you can see, we provide a number of different ways for you to add a new API, including native integration with some of the Azure services, such as Logic Apps, App Service, and a Function App. So in this case, I will click on Logic App and click on Browse, and this will show all my Logic Apps with an HTTP trigger. So let's just search for my Logic App. Okay, so we have found our Logic App to import. Let me click on that and select that. And let me provide a suffix of this API, which will be used in the public-facing URL of this API. Okay, let's click Create. So during this time, API management will try to get the API definition of this Logic App, and we'll also set up authentication between the API management and the Logic App. Okay, so now as you can see, my Logic App has been imported. A new API has been created in my API management instance called process orders, and it has one operation because my Logic App has one HTTP trigger. On the right hand side here, what you see is our request response processing flow, and I can apply policies to the inbound and outbound sections that will manipulate my requests and the responses. So my API has been imported now. The next thing I want to do is that I want to apply some policies to my API, and I also want to test this API. So to be more productive, I'm going to switch to my VS Code and will use the API management extension to perform these operations. Okay, I'm here in Visual Studio Code, and as you can see, I've already installed the API management extension. So if I click on the Azure icon here under API management, I can see my subscription and all my API management instances. And this is my demo instance. And here we can see its sub-resources such as APIs, gateways, and named values. And under APIs, we can see our API, which was imported from that Logic app. And under this API, we can see its operations, and we can also apply policies to this API. So the next thing I want to do here is that I want to add a throttling policy to this API to protect it from misuse and abuse. And our throttling policy is called rate limit by key. So let me click on the policy node here. This will open the policy editor. And if I type something here, as you can see, the policy snippets are working, and we can just pick one from the list. I will choose rate limit by key, which is our throttling policy. And I'm going to say I want to allow 3 calls every 20 seconds, and I want to throttle based on context dot. You can see that autocomplete is also working here, and just pick subscription and subscription ID. Okay, so let's save this policy and upload it to the cloud. Okay, so now we have inserted this rate limit policy, and it has been uploaded to our gateway on the cloud. So the next step is that we want to test this API to make sure that our policy works. So to test this API, I can just right click on the operation and select test operation. This will open the REST client with all the headers and the URL already filled out. And for the subscription key, I've already created an environment variables. It's already inserted here. So now all I need is to provide a payload. Okay, so this is our payload. Essentially, we want to create a new order with customer ID and item ID and quantities. Okay, so now I can just click on send request. Okay, and we immediately get a response from this API and from that backend logic app, right, with our order ID. So let's try to make a few more calls. As you can see, the fourth call has been throttled and it tells me that rate limit is exceeded. I need to try again in 6 seconds. This shows that our rate limit policy is working. Okay, this is how easy you can explore, modify, and apply changes to your APIs in this VS Code extension. There are a lot more other features, but for the interest of time, I will not delve into these features today. As I mentioned, we want to leverage Visual Studio Code as an IDE to provide a better experience to work with our policies. I have just demoed the experience for authoring policies. In addition to that, we also want to allow you to debug your policies in Visual Studio Code, just like how you debug your code. So I want to give you a preview of this feature that we are currently working on. It is not available in production yet, so I'm going to switch to another instance of Visual Studio Code, which connects to our pre-production environment. Okay, so I have just switched to our pre-production environment, and here is a demo instance with an API. So if I right-click on one of the operations of this API, now I have the option to start a policy debugging. If I click on that, it will start a debugging session connected to an API gateway. And also it will open the REST client for me to send a test request. So if I click on send request, okay, as you can see, we have entered the policy pipeline and it has stopped in the very first policy of this operation. So here I can choose to single step through each of the policies. I can also set breakpoints at individual policies. Also on the left side here, I can view all the variables that are available in this policy context. Okay, so this is just a sneak peek into this policy debugging feature. We are planning to make this available as a preview in the next few months. Okay, so let's switch back to our previous demo in production. Okay, so now we have published our Logic app as an API in this API management instance, and our Azure hosted API gateway can communicate with the Logic app on Azure, and everything is working, right? As I mentioned, our self-hosted gateway is now generally available. So in the second part of this demo, I'm going to show you that I have a gateway running locally on my laptop, which can also communicate with this Logic app. So for this demo, I have created a Minikube cluster on my laptop, which is a very convenient way to play with Kubernetes. So if I go to the Kubernetes Explorer here, you can see this is my Minikube cluster on my laptop, and there is a deployment for the local gateway. And this deployment includes a pod for the local gateway, which runs our container image, and also includes a service for the gateway. So now it seems everything has been deployed, everything's working. So all we need to do is to add this new API to this local gateway so we can use it. Okay, so if I go back to the API management extension, so under gateways here, we can see our local gateway. Currently, it has no API. So we will just right click and say add an API to this gateway, and we will pick the process order API that we just created. Okay, so now this new API has been added to this local gateway, so we can use it through the local gateway. So now let's go to the terminal. What I'm gonna do is that I'm gonna try to get the URL of the local gateway service. Okay, so this is the URL. I'll just copy that, and I'll replace the URL of here, which was the URL for the cloud hosted gateway. Okay, and now if I click send, we also got a response. So in comparison, this API call did not go through our Azure hosted gateway and went through our self-hosted gateway, which was running on my laptop locally. With this architecture, any local clients can just make API calls through the local gateway, and cloud-based clients can make API calls through the Azure hosted gateway. Okay, so at this point, we have two gateways running, one in Azure and one in my local environment, and they are both working, right? And as you may have noticed, currently both gateways communicate with the Logic app which is deployed on Azure. It would be great if we can have the Logic app running in the local environment. So for local traffic, they don't have to travel outside of the local environment. So with that, I'm going to turn it back to Matthew, who's going to talk about their future plans around this area. Thank you.
Thanks, Meow, for a fantastic demo. And as you can see from the slides, we're going to go into another one straight away. And this is something brand new that you can get access to later on this year with Logic Apps. Okay, now time for another demo. We talked earlier about how Logic Apps and API Management are tools that help developers be more successful and do more. And what this demo is really about is some exciting new changes we've got coming to Logic Apps later on this year that really put the developer experience at the heart of what we're trying to do and make using Logic Apps fantastic, even better for developers. What you can see here is VS Code add-in. Obviously, Logic Apps has a VS Code add-in today that allows you to edit the text files behind Logic Apps, but this update has a bunch of new changes in it. So what you can see here is we have a local project. So this project is actually running locally on the developer's machine. If I go to the file system, you'll see we have a number of workflows. If you're familiar with the workflow JSON from Logic Apps, this won't be a surprise to you. So if I open this up, this will be very familiar. This is how we define Logic Apps in the code behind them. What's new is that I can now click on this workflow and open this in the designer. And so now we have full designer support in VS Code running locally on the developer's box. So I can treat this just like I would any other Logic app. I can add actions or parallel branches here. Some things to call out that are noticeably different. This SQL query here, this is connected to a SQL server running locally on my machine. So when I run this query, it returns results from the database, the AdventureWorks database I have running on my machine. The other thing is we have invoking a function here, and this function is this one here on the left, math function. We're calling that from this Logic app running locally on this machine. Some other things to call out, and I can do that from a second workflow. If I open this in Designer. So this is pretty much a blank workflow with a request response in between. But if I want to add some more action to it, you'll notice that we have on the action panel here an option between built-in and Azure. And what I can do is I can create an explicit connection up to Azure, up to our connector infrastructure, and I can pull down the list of all the connectors that I can use within Logic Apps from here on my dev box. So for example, if I wanted to connect to Outlook Office 365 to send an email, I could still add that action into my Logic app here and use it. Let's close that for now. And what I'm going to do is actually kick off a build process. And that's going to tell you a little bit about how we've actually achieved this. So that will open the terminal window. And one of the things you might be able to see here in the recording is what will pop up is the functions logo, because this is all running on the Azure Functions runtime. So what we have here is Logic Apps running on the Azure Functions runtime. Hopefully the build's going to speed through. I am only running this on a laptop, but will show us that the workflows have been compiled into functions running on that functions runtime and are available for me to execute. So there we go. We see the workflows that I've created. I'm going to go and run stateful 1, a very inventive naming I've put in place for this. So here is stateful 1. Notice I'm calling it on a local host address. I'm going to kick it off. Now, because we're running on the functions runtime, there will be a little bit of a cold start the first time I run this. So a few seconds to run here. If I run it again, I should find that it's running faster every time I'm doing that. Okay. So the other thing to point out is also that you still have fidelity for run history. So if I go into Overview for Stateful 1, you'll see that I have a list of runs that I've actually performed in this Logic app popping up. So we can see the ones we've just done there. And I can still get the run history for this app as well. So I can look in here, see the SQL that went through this action. Now, quickly talking about this run history, the way in which Logic apps persist this run history is by storing it out at each step. And that gives Logic apps the characteristics that means it's very easy to do things like store the history of what's actually happened or rerun it should there be a failure. And we do this by persisting out. One of the problems with this is obviously that persistence, it costs resources, it costs time. And one of the bits of feedback we've had from developers recently is that what they would really like to do is be able to have the choice of choosing whether to actually persist that information or use the concept of building that Logic app, that logical flow of actions, but maximizing how low the latency is in the Logic app and not having to worry about persistence. So the other thing we're providing as part of this release is the ability to choose between a stateful and a stateless workflow. So I've got two examples of that here. So this is an example of a stateful workflow. And you see the way this is designed is to run through a number of actions, creating an HTML table. It takes a little time to process so you can see the difference between the actions. The stateless workflow is exactly the same. So when I created the workflow, I was given the option of do I want to choose a stateful or a stateless workflow, and when I open it out, I'll see it behaves exactly the same, even though I've chosen this option on how I'm going to run the workflow. We'll test that in a second. Other thing I'm going to show you is that I can take my local project here and I can deploy it up to a function app, to Azure. So I can take all the workflows I've created, I can deploy this app, I can choose my subscription, I can choose an app that I've created to deploy it to, and then that process will deploy all the work I've had created locally onto that app. Or I can take that local project and deploy it to my source control solution, CI/CD pipeline, as I wish. We're not going to do that right now. I'm going to hop across to a browser window. And this is the stateful and stateless workflows that I just showed you running here in the cloud. And as you can see, they have a stateful and stateless type. To see what effect that has, I have some Postman windows here calling those apps. So let's give that a shot. Again, first time maybe a little slower spinning up. So that's 998 milliseconds running the stateful app, stateless. That came back in 250 milliseconds. So that's 4 times faster. And this work is something we're still currently working on. This is not quite ready for release yet, but you get an idea of the benefits of running the stateless version of the workflow as opposed to the stateful. And again, application solutions are likely to have a combination of ones that need the persistence and ones that don't. Final thing that I want to show you is obviously as we are running on the functions runtime, we have the ability to do things that the functions runtime provides. And you'll see here that there is a Docker file included as part of this solution. So what we can do is now build a container from the solution we've created locally on the developer machine and run it in container infrastructure. I'm going to just do it now on Docker running on my machine. So I'm going to kick that off. And obviously this then gives the ability to take that container and run it anywhere you want to run containers. So for example, a Kubernetes cluster. Okay, that's booted up, so let's just prove that worked. Go to localhost 8080. Here we are, there's the infrastructure, and test one of our logic apps just to prove they're there. Hi from logic apps. So, just to summarize what we've gone through, we've shown logic apps providing a great developer experience running locally on the developer's machine where they want to build their logic apps, with connectors that connect to local resources as well. Or we can connect to cloud resources using the existing connector infrastructure provided by logic apps. We've shown the performance improvements that can be achieved by using the stateless mode for logic apps, allowing developers to choose which way they want to deploy their logic apps depending on their use case. And we've shown how you can also use the functions runtime values that it provides us to actually deploy logic apps to a Docker container, so you can choose to deploy your logic apps any way you wish. So I hope from that demonstration you can see where we're headed with logic apps and how we're trying to make sure that the experience we give to developers makes them as productive as possible and meets them where they are. This feature and this set of features will be previewing later this year. Exact details and timing will be announced later. However, if you want to get involved, we are accepting limited numbers of participants to sign up and get involved in our private preview. If you're interested in doing so and can share a bit more details on where you would like to use the new features and how you can provide us feedback, the link here you can go to sign up, and we'll be in touch. So just finally a word about hybrid, and I think from what Meow talked about with the self-hosted gateway for API management, and what I've shown you with logic apps running on the functions runtime, allowing you to deploy to a Docker container, you can see where we are making steps to broaden the options you have for deployment of these services. You already have the ability to connect to on-premises using things like gateways and relays with the on-premise data gateway, I should be clear, which is a type of relay using logic apps. Both API Management Premium and Logic Apps Integration Service Environment allow you to connect using virtual networks, but the ability to also deploy versions of these services using Docker containers is something that hopefully you've seen from this session. It will be a feature that's available soon. I think if you want to find out more about where Azure is heading all up for these hybrid scenarios, I would strongly suggest you look for sessions at Build to do with Azure Arc to find out more about that strategy. So just a summary of the takeaways. I won't read them out again. And just to say that there's more API management if you're interested. Mike Budzinski from the team will be hosting another on-demand session all about the developer portal and setting up your APIs to be served up. Finally, if you want links to get involved more with API management, there's details there. We have reference architectures that we cover the whole of integration services in Azure at that aka.ms address there, and then that link again for registering an interest in the preview at the bottom. So that's the end of our on-demand session. Thank you for staying with us through it. would be more than value your feedback if you want to let us know how you felt about this session. And thank you very much.